This video will cover the alkylation of enolates. In this reaction, the alpha proton of the ketone is removed with strong base in the first step, lithium diisopropylamine, and in the second step is used to attack the electrophile, typically an alkyl halide or an alkyl tosylate. This produces the alpha substituted product. It is important to note that this works only with ketones, not with aldehydes, because treatment of aldehydes with LDA produces many side products. Additionally, this reaction works best if there is only one type of alpha proton. If there is more than one type of alpha proton present, we will get a mixture of products because both types of alpha proton can be removed by the strong base, and therefore those carbons can act as nucleophiles. Typically then, we want to use a symmetrical ketone. The final thing to note is that we do use the strong base, lithium diisopropylamine, rather than hydroxide or alkoxide ion to form the enolate. The reason for this is because hydroxide ion and alkoxide ion, in addition to being very strong bases, are very strong nucleophiles. They're too nucleophilic and would react with the electrophile in step 2 if we tried to use them to form the enolate. Instead, we use LDA to form the enolate and then add the electrophile. Now let's look at an example of the reaction and mechanism for the alkylation of enolates. If we treat this ketone with LDA followed by ethyl bromide, we will get the following product. Next, let's look at the mechanism. In the first step of the mechanism, the diisopropylamine deprotonates at the alpha position to the ketone. This produces the lithium salt of the enolate ion. The LDA converts the ketone completely to the enolate ion. In the next step, the enolate ion attacks the electrophile, kicking off the bromide leaving group to produce the final product. Remember to always count your carbons in this type of problem. We start with 3 carbons in the ketone and add 2 more carbons in the electrophile. These correspond to the following carbons in the product. Also remember that we're forming a bond between the enolate carbon and the carbon that used to be bonded to the leaving group. This will help you properly predict the products of these alkylation reactions.